here's the deal on hyperbolas, y'all. I'm going to fill in some blanks and kind of draw at the same time. Okay, so the standard form for a hyperbola, this line right here, y'all, it's still two fractions that equal 1, but you're subtracting. So I'm going to draw two fraction bars with a minus sign in the middle. It still equals 1. Same for a horizontal. Two fractions subtracted together still equals 1. But if you go to where it says A is always the first denominator. And remember, that wasn't the case for ellipses. A was just the biggest for ellipses, but A is always first. So if A is always first, then it's A squared and B squared at the bottom no matter what. So this is A squared and B squared. So how are you going to tell whether it's vertical or horizontal? The numerators are going to start changing places. So look, over here, the y is going to come first, right? Y minus k squared in parentheses. And then write x minus h squared. That's how we know it's going to be a vertical. Now over here on the horizontal, put x minus h squared, then put y minus k squared. So that's how we'll know. So on ellipses, the bottom number changed. On hyperbolas, the top number changes. All right, so y'all, the center is still HK. We're going to write HK on both of these lines. And then my little graphic up here, I know for certain the center is at the origin because it's where the two asymptotes intersect. All right, so what is A? It's the same as it was as an ellipse, guys. A is the distance from the center to a vertex. The distance from the center to a vertex. So the A value is right here because it's vertical. That's A. So there's a vertex right there. Same in this direction. That's A. There's a vertex right here. All right, sideways. So that's the A value. All right, so vertices for a horizontal are going to be up and down from the center, which means H isn't going to change. So it's going to be K plus or minus the A value. But if it's sideways, then it's going to be left and right. So it's going to be H plus minus A, but the K value stays the same. So remember, vertices are always on the major axis. That's what this blank is. Vertices are always on the major axis. All right, foci, A squared, B squared, C squared. There's foci. The foci are inside the branches. So the foci are going to have the same behavior that we wrote right here, but it's just going to have a C. So the foci are going to be up and down C values for a vertical, and then left and right for a horizontal. And remember, the C value is, it almost looks like this, the distance from the center to a vertex, but we're going to write the distance from the center to a focus. So C is the distance from the center. to a focus. Okay, so if you guys remember, the foci were inside the ellipses. They were closer to the center than the vertices were, but not here. They're farther away from the center. So like if this is a vertex, then the center is right there. I'm sorry, the foci is right there. The focus is right there. Same here. If this is a vertex, then the focus is right there. Sideways, my purple is going to be the focus. So if they're farther away, then the distance is farther. If the distance is farther, then it's going to be a squared plus b squared equals c squared. So remember, whatever sign is in standard form, you do the opposite. That's a minus, we're going to add. So the foci are farther away. All right, I'm going to give you the equations for the asymptotes. The asymptotes are these slanted lines right here, but we're going to use this invisible rectangle box to draw the asymptotes. But here's the equation. It's going to be the same for both lines. You're just going to copy the exact same thing for both the lines. It's going to be y equals k plus or minus. You have a slope of a over b, because it's a line, right? A over b. It almost looks like point slope form, but it's not, right? X minus h in parentheses. So you're going to write the same exact thing on the other line. Same exact thing. Identical. So these are asymptotes, guys. Oh, and you know what graphs do? Graphs love asymptotes. They just don't touch them. So you're going to have a branch, one on top of the other for a vertical, and you got to hug your asymptote. Same down here. Get as close as you can, but you cannot touch the asymptote. And by the way, make sure you go through the vertex. Everything is invisible on here except the vertices and the branches. Here's your side-by-side branches for your vertical. Go through the vertex, hug your asymptote. Y'all are going to need a straight edge today, because remember, we're not going to do the equation. We're going to just draw it from the invisible box, and you got to have a straight edge. You do. You have an ID. These make the best straight edges for the graph. All right, let's go ahead and get started. I'm going to kind of make this a little bigger. All right, find the listed information and graphs. So we have two equations. They're being subtracted. I know it's a hyperbola, and x comes first, so I know that it's horizontal. All right, if it's horizontal, my center, my vertices, and my foci are all in a horizontal line. The a value is always just the first denominator, rooted, so we're going to write 4. B is the square root of 25. Now remember, C, you add the squares together. So 16 plus 25 is 41, and then you square root it. And y'all, there's no perfects in 41. So just write the square root of 41. The center is HK, so let's write -2, +1. Now remember, it's sideways, it's horizontal, which means the vertices are going to be 4 places to the left and then 4 places to the right. So 4 places to the left of -2 is going to be -6. And then 4 places to the right of -2 is going to be +2. All right, and then your foci, remember your foci are even farther away, but it's still horizontal. So it's going to be -2, and then right and left, the square root of 41, and then your k value of 1. Okay, let's plot what we know so far. So when I plot these guys, this -2, +1, I'm going to make that a fairly big dot because I really want you guys to see everything kind of stand out. So my center is kind of huge. And then let's go 4 places right and left and plot a vertex. So 1, 2, 3, 4. Oh. That's why I have this, because I make mistakes all the time. Of course I make a mistake when I'm videoing. And of course this is not working. So what are you doing? You're plotting it the right way. And I'm sad right now because my whiteout's not working at all. And I'm still recording. I should hit pause, but I don't hit pause. Y'all plot your vertex, go 4 places right and left. Sorry. So -2 is going to be to the left of the origin. It's going to be right here. Wow, I did that all wrong. I don't know. Okay, that was never, ever there. -2, +1. 6 places, or I'm sorry, 4 places to the left. 1, 2, 3, 4. There's a vertex. 4 places to the right. 1, 2, 3, 4. There's a vertex. Okay. Foci. Now we're going to go root 41 places away. Y'all remember root 41 is going to be 6 point something. So 1, 2, 3, 4, 5, 6 point something. 1, 2, 3, 4, 5, 6 point something. Okay, so there you go, guys. Everything is in a horizontal line. Makes sense because it's a horizontal hyperbola. Now we're going to draw the invisible box. This is when you deal with the b value. I hadn't talked about the b value at all. So the b value is how far away it is from the center in the opposite direction. So if this is horizontal, we're going to go 5 places up and down. 1, 2, 3, 4, 5. Going to draw a little dash. 1, 2, 3, 4, 5. Draw a little dash. So the invisible box stops on the same exact line where you plotted your vertices. So I'm drawing an invisible box, but the sides are on the same line where the vertices are. And I know to go how high because the height up and down is the b value. All right, do you guys see my little box here? Any questions on that box? So the box is invisible, and the box is important because we need the asymptotes, and the asymptotes are important because we need the branches. So, but the only thing that's really important on the box are the corners, because the corners are actual points on the asymptotes. So from now on, down here on this graph, I'm only drawing the corners. You can draw the whole box if you want. I'm only drawing the corners. All right, speaking of the corners, remember it makes up the asymptote. So find your straight edge, line it right through the center and the corner. And you can draw all the way across. That's totally fine, but it has to be dashed because remember it's invisible. I'm not drawing in the center. I'm only drawing on the outside. So there's my asymptote. That's one of them. Remember, there's two. So you're going to do the same thing. You're going to line it all up. Don't forget it has to go through the center. That's where the two asymptotes intersect anyway. It has to go through the center. It's the B value. But it goes through the vertex. See how it goes through the same line as the vertex? And then it's going to be B places up and B places down. Okay, now do your thing. Draw your branches, hug your asymptotes. You can if you want. It's just not necessary, and I like my graphs less cluttered. You can certainly go ahead and connect them. Just make sure it's dashed.
Can you draw at the top?
Yes, you can. But it has to be dashed because it's invisible. So it needs to look like this.
And the asymptotes also need to be drawn?
Yes, because they're invisible. They're not part of the graph. They're attributes that shape the graph. Now listen. If I plug this in on Desmos, everything is invisible. The only thing that you would see is what I drew with this purple pen. So you got to make sure that your box is dashed and that your asymptotes are dashed. Good question. Any other questions on number 1? All right, let's go ahead and look at number 2. And y'all, I don't know why. I thought I was going to be tricky, and then I just regret it. This is a teacher gotcha. Don't fall for my tricks. It's so silly. I'm a little embarrassed that I wrote it like this. You're not going to fall for this silliness. Notice you have a negative fraction in front. We don't have negative fractions in ellipses or hyperbolas. It always starts with a positive fraction. Obviously, this hyperbola is written the wrong way, but you're not going to worry about it. Just rewrite it the right way. Write the positive fraction first. Let's write it up here. So y plus 2 squared's first. That y denominator is 4. Then you're going to write the negative one. So write your negative, and then write your x minus 3 squared over 9. Don't fall for the silliness. That's a silly little way to try to get you. And I'm not going to get you. You're not going to fall for it. All right. So when it is written in correct form, guys, your y value is first. So if your y value is first, we know it's vertical. So let's write vertical. All right, A, B, and C are still the same. So let's look at how we wrote it correctly. The A value is 2. The B value is 3. The C value is the root of 13. Any questions on those numbers? All right, remember it's vertical. So if the center is positive 3, negative 2, then your vertices are going to be sideways from that. They're going to be 2 places to the left and 2 places to the right. I'm sorry, it's vertical, it's up and down. 2 places up and 2 places down. Your vertices are above and below the center. So 2 places up is going to be 3, 0. 2 places down is going to be 3, negative 4. And remember, your vertices are up and down too, but they're even farther away. So, I'm sorry, the foci. The foci is going to be 3, negative 2, up and down, positive, negative, the root of 13. All right, let's go ahead and plot what we know. The center is at positive 3, negative 2. 1, 2, 3, 1, 2. Pretty sure I graphed that one right. All right, let's plot our vertices up and down. 2 places up, 2 places down. Remember, your foci are up and down too, but they're even farther. The square root of 13 is 3 point something. So from the center, go 1, 2, 3 point something. Center, 1, 2, 3 point something. All right. Okay. Now it's time to draw the box. And remember, the most important thing about the box are the corners, because the corners are the asymptotes. So the corners are going to be on the same line as your vertices, but they're B places away from the center. So B is 3, so I'd go 1, 2, 3. This is a corner right here. This is also a corner. 3 places away. So those are the corners of the invisible box. And the only reason we need the invisible box is because we need the asymptotes. Yes. So this is going to be don't forget when you use your straight edge, and you have to use a straight edge because we're not going to use the equation. Use your straight edge, make sure it goes to the center. Now remember, all this stuff is invisible. That's why I don't really draw it in the center, because I like my graphs as least cluttered as possible. If this was not invisible, if this was part of the parabola, remember we would be drawing solid lines, and there's no way that I would skip drawing in the center. But since it's invisible, it's okay. Y'all, draw your branches, hug your asymptotes, your friends or your asymptotes. Remember, the only thing that you actually cross is the vertex that you drew on the top and bottom. Everything else is invisible. And that's it. Do you guys have any questions on your hyperbolas? Any questions?